Let's talk about factoring trinomials where a is not equal to 1. The first thing you want to do is to make sure the trinomial is in standard form. That's ax squared plus bx plus c. And the next thing we want to do is similar to when a does equal 1, but a little bit different, is we want to find a pair of integers whose product will equal a times c. So a times c this time instead of just c, and whose sum will equal b. So that part is the same. Write out the factors using a leading coefficient of a in both binomials. So we'll look at that in just a second. And then the fourth step is to divide by factors of a. So I'll show you what that's talking about also with our examples. And then of course you can always check your answer using the FOIL method since these will be binomials. Let's take a look. So for example 1, we have the trinomial 2n squared, so notice a is 2 this time, 2n squared plus 15n plus 7. So our first step is to do a times c. So 2 times 7 will give me 14. So I need to find a pair of numbers whose product is 14 and whose sum is still going to equal b, which in this case is 15. So the a times c part is what's new. So we look at 14. What numbers give us 14? 1 times 14, 2 times 7. What numbers will add to give me 15 would be 1 and 14. So we have 1 times 14 is 14, and 1 plus 14 is 15. Now this part is new as well. We need to write it so our leading coefficient is a. So you write your binomials with 2n plus 1 and 2n plus 14. We call this wrong way factoring because that's actually something wrong. 2n and 2n, when we multiply, would give us back 4n squared. So that's 1, 2 too many. So we need to take out factors of 2 to make us have the right number. So factors of 2 that will divide evenly would be a 1 and a 2. 1 times 2 is equivalent to 2, and that way we're not making fractions because we definitely don't want to do that. So then this binomial stays the same because dividing by 1 didn't change anything. So I bring down 2n plus 1. This one is going to become n plus 7 because I divided by 2. But see now, if we check it using our FOIL method, we'd have the right number there for our first term. 2n times n would give us back 2n squared. That would be correct. 2n times 7 would be the outside, so that'd be 14n. 1 times n would be inside, so 14 plus 1 would give us back 15n. And 1 times 7 for the last term would give us back 7. So we could check our answer using the FOIL method. Let's look at example 2. A times c. So a is 3. So let's say 3 times 10. Our trinomial is 3x squared minus 17x plus 10. So a times c would be 3 times 10, which is 30. So I want to multiply to get 30. I want to add to get b, which in this case is negative 17. So like we talked about with the other trinomials is if I'm going to multiply to get 30, but I need to add to get negative 17, I would have to have some negative numbers to add up to equal negative 17. So let's start with negative 1 times negative 30. But they don't add to give me negative 17. How about negative 2 times negative 15? They look like the right pair. So we have negative 2 times negative 15 equals 30. And negative 2 times negative 15, or excuse me, negative 2 plus negative 15 adds to give me negative 17. So then let's write down, again, use a in both binomials, but then we're going to fix it. So we have 3x minus 2. I'll put that over there like we did last time. And 3x minus 15. But again, notice 3 times 3 would give me 9, so that's too big. I have to take out one of these extra 3's. So I want to make sure I divide these binomials by something that would go evenly, but that they're factors of 3. So 1 would divide evenly here, and 3 would divide evenly for my second binomial. So my final factors are 3x minus 2 and x minus 5. Those would multiply back together again to give me exactly what I started with. Remember, factoring is a rewriting of what you were given. So these two things should be equivalent statements. We've just rewritten what we started with. Now let's look at our third example. We have 6m squared plus 25m plus 11. So let's start with a times c, 6 times 11. So we need to multiply to get 66. We need to add to get b, which in this case is 25. Now these are both positive, so we can list things that give us 66 and check and see which pair will add up to be 25. So 1 times 66, 2 times 33, 3 times 22. That looks like the right pair. So 3 times 22 multiplies to give us 66 and will add to be 25. So let's write our answer, or almost our answer. We have 6m, then we put our numbers in, plus 3, and 6m plus 22. But we have an extra 6 that we've got to take out. So we could either take out 1 times 6 or 2 times 3. So in this case, it looks like our first binomial would divide by 3 evenly, and the second one would divide evenly by 2. So now our final answer would be what we get after we divided. So we have 6m divided by 3 is 2m, 3 divided by 3 is 1, 6m divided by 2 is 3m, and 22 divided by 2 is 11. And again, we could check using the FOIL method. So let's look at a few more examples. Now, for example 4, do you notice anything special about this example? I'll give you a second. All of these numbers have a greatest common factor. So when that is the case, you want to take that number out. It not only makes your work easier, but it'll make your answer correct. Because if you are factoring, you always want to completely factor the polynomial. If you don't take out and take apart every piece that you can, then you have not completely factored yet. So to leave the greatest common factor there would be wrong. We want to take it out. And it's easier to take it out in the very beginning. So each of these numbers would have a 5 in common. So let me switch back to purple. We've got 5, and we would have our trinomial left over would be 5x squared, because those multiply back to give me 25x squared. We have minus 2x and minus 3, because then again, if I distribute, I would get back what I started with. 5 times negative 3 is negative 15. So what's left over, then we can factor like we've been factoring the other examples, and just leave the 5 out front for now. It'll be part of your answer. So now I look over here and I say 5 times negative 3 would be negative 15. So I've got to multiply to get negative 15, and I need to add up to negative 2. So negative 15, and I have to add up to negative 2. So that can be kind of tricky. Why don't we just list factors of 15 and we'll see which ones we can get negative 2 from. So 1 times 15, 3 times 5. So which pair would give us 2? And in this case, a negative 2. So 3 and 5 would work. And then we think about which one would need to be negative. Only one of them needs to be negative, because then they need to multiply to get negative 15. If we made both negative, then they would multiply to be positive 15. So negative 5 needs to be negative. So it'll add up to -2. So now we've got 3 times -5 would multiply to be -15, and 3 plus -5 adds up to be -2. So now we have the right pair of numbers. That part of this process is the most important part. The wrong pair of numbers is just simply the wrong answer. So you want to spend your time wisely right there and make sure you have the right pair of numbers. So we bring over our numbers and put 5x in each parentheses. And we put the +3 and the -5 that we found over here. And then we bring down the extra 5 that's just hanging out there because it needs to be part of our answer, so we don't want to forget about it. But we have an extra 5 in here, so we've got to divide by factors of 5. Now 5 is a prime number, so it only comes from 1 times 5. So I'm going to divide this one by 1, and this one would divide evenly by 5. And then I'll have my answer. So I have 5x plus 3, and on this binomial we end up with x minus 1, because we divided by 5. But bring down your factor of 5. That way, if you multiply all of this back together again, then you would get what you started with. If you don't bring down the 5 that you factored out, then you would end up with this trinomial, but not the one you started with. We always want to be able to end up with what we started with. So we have one more example. Now, have you noticed anything about our last example? Yep, they have a greatest common factor as well. All of these numbers would divide evenly by 11. So if we take out 11, and since we're factoring, we want to leave 11 out here in the front, write what's left over. We end up with p squared plus 7p plus 6. Now by taking out 11, those numbers got a whole lot smaller. They looked really big at first. But now they're much smaller, and notice my a value is now equal to 1. So this trinomial is actually like the ones we first talked about. So we would just simply need to say which numbers will multiply to give me 6, and which ones would add to give me 7. Now some of you might be thinking like, well, what if I forget and I do a times c instead? Well, that doesn't hurt anything because a is 1. So 1 times 6 is still 6. So you wouldn't hurt anything if you thought of it that way. So we think about 6 comes from 1 times 6 and 2 times 3. So 1 and 6 would help me to get 7 when I add. But these trinomials are easier to write because a is just equal to 1, and so you don't have to do the extra step of dividing by the extra a value. So let's bring down 11, and then we could write our factors. We've got p plus 1 and p plus 6. But we don't have to divide since p doesn't have anything extra right there. And again, if we multiplied it all back together again, we would get just what we started with.